So first, yes, I'm Dullin, so I am conducting research in the LAPDC private lab in France, founded by Jamet, who is here. Yeah. And also I want also to thank Karl, with which we make many experimentation, the telekinesis practitioner, and so with that we were able to do the experiment we present today. So our current research is to look to the potential influence of potential human influence on the spin of light object, and we are focused on looking to the aerodynamic thermic forces, leaving the other force as were eliminated, as we present in precedent work. So what I will present today is quickly make a sum up of what we present in Convention 217 and the method and the result we obtain. And I will present a new result with new equipment, easy to set up, and with high signal to noise ratio. And I will propose at the end maybe some proposal about PK research. Trying by telekinesis, but it didn't work. I'm maybe too stressed. So, precedent experiment, we use a target, which is a plastic cup, as you can show you quickly. So a plastic cup of 2.4 grams, so which is a bit heavier than this one, which are some tenths of gram. We saw very many things about pinwheel, if you look to the internet sometimes, and so many, it's very often tenths of gram. In the precedent studies, we present that So in our present experiment, we show that the mechanical, magnetic, electrostatics, and radiation pressure forces was not relevant in the kind of scenario we are looking for, and so the only force which was left as candidate for the potential motion of the target was the aerodynamic thermics current. So we use PIV techniques in order to measure. Our focus is to measure the airflow speed around the target. So we use a PIV technique, which stands for particle image velocimetry. In fact, we look at So we look at smoke particles, which are driven by the air and which are eliminated by a laser, and we use image processing to calculate the speed of the smoke particle. So how do we work with that? We use a semi-confined environment, like here, which is look at the telephone booth with a curtain, which is here. You can find here the table inside the cabin. We put the target, we put some smoke in it with a smoke generator, and the practitioner, the telekinesis subject, sits here, put his hand here, and try to move the target without touching it and keeping his hand still. So we eliminate here the smokes. So we reveal a thin horizontal slice of air, which is crossing the dome, plastic dome. And here there is a camera setup vertically that can see from above what's happening at 50 images per second. So you see the flow of the air, the target, and the hand. Okay. So from this, so we take the video of 50 images per second. We make an image processing to identify the smoke particles on each image, and we calculate between two images the difference of position of the particle, and so the speed, knowing that there is 20 milliseconds between two images. Okay, and then we represent on the screen the vector. So here, sorry, come back. So here you have the smoke moving around the target, and you can see here the representing vector of the speed of the flow around the target. So higher is the vector, bigger is the vector, bigger is the amplitude, and you have the direction of the flow. So in our precedent experiment, we in fact conducted 10 experiments in 3 set categories. The first one was a experiment where we generate the air with a pump. The second one was electric motor, which is generating the motion of the target. And the third one was the target is driven by the Tkiste, by a PKR, what we call a telekinesis practitioner. And so the way we compare the experience is to make the ratio between the dome speed and the peripheral airflow speed around the dome. So what was the result? The result we presented. So here you have the ratio from 0 to 9. And what we find is that for the airflow experiment, all the ratios are below 1, less than 0.5, which is something logic because the target is running faster than slower than the airflow that's drive it. Here we have the motor experiment. So in this case, we are from above 3. So it's logic also because the motor is driving the air around. So somewhere these two categories are validating the measurement process. And then if we look to the T experiment with PKRs, we have a ratio above 1, moving from 2 to 7.8. And so it means in this last case that the target was running 8 times faster than the airflow around. Sorry. So which concludes that the airflow running around, so the aerodynamic thermic forces was not the main explanation of the motion of the target. So for the new experiments, we first evaluate a minimal airflow speed in order to start the target. So it's different here. And we do that for the reference experiment, also for a PKR experiment. We improve the signal to noise ratio, and we try to use a new transportable bench, which is able to be used directly by the telekinesis subject in his home environment. And so in that point, we can multiply the experiment, and also we have a good mood factor, as we say. Coming back to the paper of Karl at Carpenter that Annalisa presented this morning, we show that with a good mood factor, we have better result. So for this experiment, we take a heavier target. So it's like this one, but you make three like that pilot. Sorry. And we use a standard stem from a carousel candle. And then, so David has developed a new bench with transportable characteristics. Some people have tried it yesterday evening at the workshop. And so how it works, there is, here is a plexiglass box with a lid, with a rectangular opening. We use 2 instant sticks to generate the smoke, so it's smoother than machinery. Here is a laser device, small laser device with a specific lens which be able to generate an air slice, horizontal or vertical. And here is the camera taking the image above. So how it works, the practitioner puts his hand around the opening, as you can see on this photo from the camera. So you see the hand and the rectangular opening. So it's a bit more difficult than the precedent experiment because the hand is above the target, okay, and above the plexiglass, as you can see here. You have the hand and you have the target. And so also it's good because we eliminate some explanation, like the one proposed by Barcollier, which was the hand was making some disequilibrium of an airflow, moving horizontally on the table and driving up by the feet of the body. The second explanation was the one of NKF, which was to say that there is a difference of temperature between the palm and the fingertip, so it makes a disequilibrium of an air current ascending around the hand. And the third one was the Albert Hofmann explanation, that in the hand you have a pulse, the blood pulse, and this blood pulse on the hand and on the wrist could make some vibration and set the target in motion. But these three explanations can't apply here because we are not at the same level than the target, we are above. So these three explanations can't apply in this case, even if they can apply on other movements. So the method, we make some reference experiment with the standard bench, static bench. So we're using pump generating air. We work on the PKR experiments, we use the transportable bench. And so we focus on the 10 first second of the motion in either case. Sorry. So how we compare the experiment, we use two parameters. So the first one is the air velocity magnitude. In fact, we look to the speed, but without the direction. And we focus on the specific area around the target, where the air is really driving the target. And the second parameters, we make some concentric cycle around the dome, and we measure the speed of the air, the tangential speed on this circle, on this area. And so we look how this tangential speed is moving, is evolving from the surface of the dome to outside. And we compare between the experiments. So here are the comparisons. So the two upper images are the reference experiment using air generated by pump. And the two below experiments are the one with a PKR. So if we look directly to the size of the vectors, which are the same scale for the four images, you see clearly that the vector on the airflow experiment are really bigger than the one in the PKR experiment. And if we look to our first parameter, which is magnitude, we have 30 millimeters per second here, we have 23 here, and on the PKR experiment we have 2.4 and 2.7. So it's a ratio of 9 between the lower here and the mean of this one. And if we look to a more precise measurement, using the tangential speed, here you have a graphic where there is the speed from 0 to 60 millimeters per second. Here you have the distance of the surface from 0 to 25 millimeters. This is the curve for the two reference experiments, and this is the curve for the PKR experiment. So there is a ratio of 10, around 10 between this and this one, and 15 between this and this one. So, but we could say, what about vertical speed? Because we are in a horizontal speed. So we have a semi-confined box with two burning sticks at the basis. So you could say that there is an airstream moving up, reinforced by the fact that there is a heat end of the PKR, and so this ascendant current with a disequilibrium could initiate a spin of the target. So we look through that, and we use a vertical slicing of the experiment with the laser. And so we are able to measure the speed of the flow in a vertical plane. So here we have 2.7 and 3.2 millimeters per second, which are in the same range that what we see in a horizontal plane, which was 2.4 and 2.7. So the vertical speed can't explain either the movement of the target. Finally, we conduct an artifact experiment. So we wanted to simulate the hand and the upper body of the PKR, meaning on the bench. So we use glasses, filled of water, and a glass jar. So here you have the glasses. Sorry. Here you have the glasses. So simulate the hand, and here it's the wrist. And here you have the big jar, simulated the body leaning on the bench. And we make some different experiments with different temperature. From normal temperature, we would say 37 degrees at outside, to 90 degrees. And we did not observe any movement of the target as soon as the PKR was not in the room. So also we can say that with this approach, so airflow visualization, we avoid many tricky potential because if you make some airflow, for example, air mouths blowing or hands move, you can directly see on the video and also on the vectors of the speed which are calculated. So it's difficult also with this semi-confined box to induce mechanically a spin of the target inside. It's plastic, it's not magnetics. We show also in previous presentations that static electricity could not apply here because you can make some movement with static electricity. With a hand still, it's only half turn in the side and half turn in the others. Or you can move if you run around with your hand, but in this time you can detect that immediately. And we are looking only to movements that at least are several turns. And for this experiment, it is about 4 minutes, 4 minutes spinning, continuous spinning of the target. So finally, the conclusion. So we confirm the Poisson reduced with a 10 signal-to-noise ratio, so that the aerodynamic forces and aerodynamic thermically induced forces are not the main explanation for the motion of the target. We show that even if application of Barclay explanation can apply elsewhere, it can apply on this specific presentation. And so we move forward to make some experiment around the confinement factors and the distance factors. What we want to see is to see with others if we can elaborate a new space in PK research. Because our proposal is that today we are speaking about micro-PK, which is a very defined space when we work about RNG and statistics, as we saw today. We talk about macro-PK, and in this area we are more about looking to books, reports on very big events like Diagnes Douglas Home, Indrisson, Rudy Schneider, and so forth, or more recently with Uri Geller, Jean-Pierre Girard, and also with poltergeist, Speckle. For all this area, there is some scientific study that has the one done by William Crookes and Rome, the one done by IME, Dr. Rosti and Rudy Schneider. And we work also, you see also the work done by SRI on Ingo Swan and Uri Geller. And on poltergeist, we saw today that there is many people working, as Walter can make a big report on that. But in fact, on this area, we are looking very many principally on exceptional events or very gifted people, which are also exceptional. So what our proposition is to focus on small, semi-repeatable physical effects, as we have in our experiment. So we are in a range of 1 to 100 micronewtons, so we are not at 800 newtons of levitation. But with this, for example, the experiment I'll show you, it was around 4 micronewton physics. So 1 to 100 micronewton, we have many things to do. The advantage is that we can make many experiments, repeat experiments, make hypotheses, and so really conduct scientific research. And I think that maybe we are very interesting to have some other coming up and helping us to go through this field. And so we bring on the table some measurement process like this. But we are very open to work with other people, and we have also already contacts with some research centers. We know that they work on this, and we will be very happy to continue to make these partnerships. Thank you.
Questions? Yes, Peter.
Sorry.
Thank you, Eric. Do you have any experimental setup where your device is completely enclosed, completely confined, without any possibility of contact with the outside air and any airflow?
First, I want to thank Peter, because thanks to Peter Mullers, we are working on the Android framework. I think he did this work in the Freiburg University, and it's a 1 century old work. So but there is many very interesting experimentation to do. The only problem is that it's all in German, so it takes time to go through. To answer to your question, yes, we have already worked on the confined systems. We already observed that we are able to make some results, but with smaller objects, lighter objects. And it was our first reflection to say, if we look only on the confined systems, maybe we reduce the capacity. And so it's why we try to work with semi-confined environment, computing by measuring systems. But it's our next steps to come back to this confinement. And we know that, for example, the box you see there, if you close on completely the box, we are not able today to run this kind of 2.4 gram of systems, but we are able to do that, you know. And some people have already success in we have the video inside box glass jar, but not so many times. So what we are looking for is really semi-repeatable effect. But what we are interested in is to look why the confinement is important, and also the distance factor. So if you push the end outside, is the target decreasing the speed? That's the case today. And why? If we come back, is it only in the mind of the people, or is it really a physical effect? So all this has to be studied.
Yes.
So one little suggestion regarding the possible distance factor. From the studies I've made regarding macro-psychokinesis, I think that the psychological factors are weighted, they weigh a lot in the PKR. So I suggest when you can make some distance manifestations of the PKR over this object, I suggest to put a camera afar from the object, so you can see it, but so that the PKR can see it through the camera, and also within the enclosement, because I believe the enclosement is just a psychological barrier to the PKR. So if the PKR is able to do it through the distance, through a video conference, for example, a Skype call, for example, you could put like the cell phone just in front of the mobile, or within the cage in front of the mobile, so he doesn't have a notion if the object he's affecting is within the confinement or not. That's suggestion.
Yeah, I think it's a good idea to don't give all the information to the PKR. About distance, we already work during 3 months with 2 PKR through Skype with a protocol specifics. And we didn't success. But before, 2 years before, we have 2 successful results, but there are less protocol. So now we come back with a more strong protocol, and we did not success to the distance to Skype. But you know, we have to continue to work on it. But I think that's a good idea to say that you don't know if it's confined or not. I think it's a very good idea. And I'm sure that Karl is smiling around that, because he's trying to work with this box completely confined. And after, there is many questions, you know, what's confinement? If there is only a hole, you know, and after if we go to the explanation, is it a problem of noise? So reduce noise, and you use, you can, as proposed by Harold sorry, I don't have the name, and Russell Tag from SRI, when they work with Windows 1, and they say that maybe the practitioner is a source of order on the ground traffic, and so more you have noise at the start, more it's easier. We don't know. So it's a part of the work we have to do on that.
Speaker, here, her question here.
I'm curious about your selection of the PKR, and if you are exploring, for example, people who do Qigong, where there are reports of people who can move from the distance, other people standing or healers, or how you're actually making that selection?
Yeah, I will go back to the precedent presentation. We are looking at attractions. So in fact, we put some things on the net, but maybe people are contacting us, and then we start to try to work with them. They send us some video. We look at how they work. We discuss about the protocol, and that's it. But we don't have 200 people to select on. I think the same problem for many labs. If you want to have gifted people, you don't find that at the corner. and also I understand that maybe you can make some prospection in some specific area like Qigong practitioner. What we can look at is that many people who are in this field are some kind meditators, but not all. We have some good examples with people who don't know about that, and they practice too. So I think we are very, cautious about the hypothesis we can do. We can put either in the physical side and either on the psychological, because now we have seen many people and so many differences. So we can define a specific profile to say that these people will do that. But you're sure, maybe Qigong, there is not so much people in France, so it's not so easy. But I think once people are interested in it, they can get it with us and we can work together.
Eric? One more question?
Sorry, just to answer to Madame. The design of the first bench was made with a girl who practiced Qigong in Poitiers. So it was much easier to work with her because she always can stay in a good state of mind, very quiet, and it was very good for results. But for the study, it is Karl who did the experiment, but he doesn't practice Qigong. So Qigong is good, but it's not all.
Oh, no, that's what I was asking.
No, that's right. Some kind of specifics.
So yeah, let's take the last question.
I was just wondering if you have any idea about the ratio, so how many PK gifted people are there in, let's say, 100 people, and did you observe whether that ability can be trained?
Yeah, so two excellent questions. For the first one, in fact, we start with more an approach that every people is able to do that. But when you go to the bench and you have to make an experiment with a good signal to noise ratio, you need to have good. It's why, for example, we take a three piled up target on this new bench, so we have better signal to noise ratio. But not so much people are able to turn it. But if I'm looking just at one, on this one, on an needle, I can find many people who are able to do that. After the problem is we have to split this between what is it physics which is working or is it telekinesis, and it's why we make all this work. Define the threshold, and also because people can try, and that's good because even if it's physics, it's good for the people to be involved. And we saw that in the workshop yesterday. Many people were interested to try, and the fact to try, it's very good. You can get people, finally, maybe at the start, they use aerodynamics, but at the end, it was telekinesis. So that's the idea.
So it can be trained, like Pellis.
Clearly, I think that it can be trained. And also you have if you leave it during 3 months or 4 months, you have a decrease and you have to come back and so forth. So I think yes, and there is a training curve. But what we can see that there is a training curve, but you get a limit for yourself. Some people have higher limits than others. As you play tennis, not all the people are able to go on Wimbledon.
That's good, thanks.
Thank you. Let's thank our speaker and then thank all of our speakers.